Okay. Good morning, everyone.
Good morning.
Good morning. Okay, so yes, I'll be talking about performance. So the main topic for DPDK. It's a bit of a back to basics for DPDK. And I will try to take my best French accent so Olivier can understand.
Thank you.
You're welcome, Olivier. This is the summary of what I want to say this morning. DPDK achieved good performances with several architecture, devices, environment, and it is making some optimization and leveraging the hardware offload, and a bit of usage, consumability of DPDK. Then the whole goal of this presentation is to show what DPDK is doing, but more importantly, what is missing in DPDK. So if you see someone you can participate in, you are welcome. Interesting. Maybe I can stop here, or okay, let's go to more details. Let's say it's obvious. DPDK is about speed and high throughput. That's the main priority. Maybe the only one, or it can be discussed. Like latency. Someone will talk about latency, especially for traffic generator. It's not discussed a lot. There is not a lot of measurements about latency, so you are welcome to give more input about that. And the other measure of speed is the jitter. It's something we don't talk a lot, maybe because we are not using a real-time system. Most of you are using Linux or sometimes FreeBSD. Is it something we want to study in DPDK? It's an open question. Then, what makes DPDK so unique? It is achieving this good performance on several hardware, and we are trying to have more and more hardware. So first, let's talk about CPU. Yes, currently it is trendy to say what DPDK is and what DPDK is not. So okay, today no need to repeat DPDK is not Intel, because we're already convinced. But yeah, that's true. The first name was Intel DPDK, and it was agreed to use only the DPDK name. Sometimes we can read still Intel DPDK in some articles or emails. I think it's better to use only DPDK for now, to strongly mark that everyone is welcome in DPDK. However, Intel is still the largest contributor, as you can see here. There is a big gap between the Intel contribution and other. So first, thanks to Intel for their participation, and other are obviously welcome to do more. What means having several architecture? It means now, when we are doing some changes, we must check if we are not doing some regression, if we are not breaking the other architectures. That's not something so obvious to do. And honestly, we cannot really do it alone. We need everyone to do that. So it's a community effort. Probably it is easier to achieve this goal if everyone takes his own duty. I mean, you are working for ARM hardware, you have to test all the DPDK features for your hardware, or your use case at least. Okay, this is the list of the CPU. So the ARM one, the IBM Power one and the Intel ones. The main library are supported now for every architecture, which is a really good thing. About the drivers, they are mainly tested for Intel 64 bits. And we don't have so much feedbacks for the other architecture. About vHost Virtio, I think now it's okay for everyone. So I think the next step should be to fill this table. And by the way, maybe some cases are missing in this table. We can fill it together if you want later. So how are we supporting several architectures in DPDK? There are several ways to do it. First, if you want to implement a function which is basic, reusable for every libraries, you have to put it in EAL. EAL is Environment Abstraction Layer. There are some directories per arch code, so you can put a file specific to IBM Power, x86 and so on. For some libraries or for some drivers, we can have a specific implementation for some architecture. Here is the example of ACL, where we have an implementation for each hardware, actually each vector implementation. It is the same thing for the drivers. The goal is to avoid to fork the implementation for each architecture. We have to keep the more common code we can. But sometimes the function is very different to have the best performance for an architecture. So in this case, it's allowed to do that. Inside the code, we need to have some if-def to say for which architecture the code is made. It is def, so it's build time. To separate code for really different CPU, that's okay. But when you are trying to do some different code for different variation of the same CPU, let's say for ECC or for AVX, it's better to try to switch your implementation at runtime. We have a function for that. We check at runtime which CPU support we have. And so when we build DPDK, we build every available optimization for this architecture, and at runtime we choose the best one. It's really important, especially for packaging and distributions. More technical about how we can do that. Currently, like for example, as I showed previously for ACL, we are creating a new file for each implementation. So this file can be compiled with the right flag to use this CPU function. And at runtime, we choose the right function pointer to achieve the function. That's something really manual, and that's okay. Yeah, just a note about the flatten attribute. That's something we are not using in DPDK currently. Maybe it could help to have more optimization, because you can inline every function called in your function. Not sure it's clear, but so using the flatten attribute, GCC is able to do more optimization in your function. Then another attribute, the target attribute, it allows to build a function specifically for one CPU capability. For example, you can write an AVX function and tell to GCC, you have to build this function with the AVX capability. As I said previously, currently we are using a whole file which is built for AVX. But we can do it just for one function with this attribute. And even more interesting, there is another attribute which is target clones. This attribute tells to GCC, you please, GCC, compile this function in several versions for each CPU capability. So here it's not about some manual optimization. You are not using some machine instructions. You are just using some C code, basic C code, and GCC is trying to use AVX or SEC or LTVEC or I don't know. It's not something we are using today in DPDK, probably because we are better than GCC to do the optimization, I don't know, but sometimes we can try. So these optimizations are often about using the vector instructions. There are several ways also to use the vector instruction. It is common to use the specific intrinsic functions from GCC. It works, but it's not common. You have, when you are using an intrinsic function, you have to rewrite your code when you want to use another CPU capability. When you want to switch from SEC to AVX, you have to completely rewrite your code. So for some simple cases, maybe we can try to use generic vector type. It's just a matter of declaring the vector type and use it with some basic C operators, like addition, assignment, things like that, or logic operators. So it doesn't work with complex case. We don't have the full capabilities from the CPUs, like shuffling the bytes or things like that. But for some use case, it can be used. Why I'm talking about this topic? Because for the maintenance, it's a really important topic. Because what are we doing currently in DPDK? We are adding some new code for LTVEC, for ARM Neon, for AVX, AVX2, and so on. And we are adding this new code in one driver on one library. And let's say I want now to do some change in the library. But I'm not an expert of IBM LTVEC. Sorry, PowerPC LTVEC. I'm not an expert in ARM Neon. How can I change this library if I'm not able to change every implementation at the same time? Because maybe I could remind a gold rule, you must not break the code of others. It's not possible to change a library without changing every implementation. So how can we manage it? That's really an open question. We can ask to experts from a CPU, we can ask to the library or driver expert to help. We have to do some coordination between us. But for sure, we are going to have some hard time about that. That's why if you can write some generic code, it's really good for everyone. But for sure, our main priority, back to my first slide, is to have the best performance. That's the main priority. And after that, if we can manage to have a well-maintainable code, that's better. Okay, now quite different questions about the drivers. Because sometimes we need to do a change in the driver interface, in the driver API. So it means, like for example, the best example is to change the mbuff structure. When you change the mbuff structure, you have to adapt the code of every drivers. It's already a hard work. But it's worse. You have to change the code of every drivers for every architectures. It becomes a nightmare. So we have to think about how can we coordinate to do such changes. That's a big challenge. And something we really should avoid when implementing a driver for a specific architecture or a specific optimization, we should keep the same behavior and the same set of features as other implementation. Do we want to have a driver who acts differently on, let's say, Intel AVX and Intel without AVX? Or do we want a driver acting differently on ARM and Intel? Is it possible to document this? Is it easy to help the users with such a driver? No, sorry not. So we have to be really careful with keeping something really consistent. In the same idea, we are using also other optimization techniques, like inlining, take care of the cache elements and prefetch and so on. But there are some small optimizations which we can do when the code is working. And we can do this optimization when looking carefully at what is the machine code for one architecture. But then you have to look at this optimization with every architecture. So now the question we should ask, is it generic enough to do this kind of micro-optimization? And again, the main priority for DPDK is to have the best performance on every architecture, yes. But we must be careful when doing an optimization which we could think is generic, but we will trigger a regression on another architecture. But that's easy to tackle this problem because we are testing the implementations on every architecture, we are testing every patches, so no problem on this side. But please just be really careful and do your validation, and most important, give some feedbacks. Yes, question about the testing, I guess?
Well, just the last thought. How do you actually trend this thing? How do you measure the performance gain?
Yeah, good question. Yeah, that's a good question. Thank you, Maciek. Maciek was asking how are we measuring the performance today? How are we monitoring the regression? There is no public numbers today for this. That's the duty of everyone. For sure, we have to work on having some more public numbers, more public monitoring, and maybe some graph with the numbers. That's something we can discuss later. But I think, honestly, that's our next main priority. We have to work on the CI, and we have to work on how we are sure we are not introducing some regression on every architecture. Because, again, back on the one of the first slides, DPDK is not Intel anymore. And that's pretty recent. So now we have to work on it. This is the list of our drivers and some features implemented in these drivers. There's a lot to say about it. Just the obvious things. Currently, we are supporting some PCI drivers and some virtual drivers. And we are going to have some system-on-chip drivers. So the work in progress is to be more generic for the bus, to be agnostic against the bus. And here it is a list of drivers for networking, but we also have some drivers from crypto. Okay, that's the status. The most important thing to say about this table is that a lot of lines and columns are not filled, and we have almost no feature which is implemented in every driver, except receiving and transmitting some packets. Why is the driver so different? Because they are leveraging some different offloads. We are working currently on a new API to leverage the flow steering from drivers. So it will be a new API. There are some work also on TSO, LRO. Recently, Olivier has added a software implementation for Virteo. And he also added some new flags from checksum offloads. So these are some new works, and we need to generalize these works and have a good implementation in every drivers. Now, an interesting topic. Like I said, okay, I come back. Just here, there are a lot of holes, a lot of gaps. How can we fill the gaps? Sometimes we have the support in the hardware, so we just have to bring the support to the driver. And sometimes the hardware cannot achieve a feature. So in this case, maybe we can have a software emulation for the feature, like Olivier done for Virteo. But we can do it for hardware drivers. Well, why should we do that? Because it's easier to use if we are sure that every drivers are able to achieve a feature. So we don't have to ask, what is my hardware? So, okay. So with this hardware, my code must be differently. So in my application code, I must do some if check. Okay, maybe it won't be performance emulation, but at least for testing and for generic application, it would be better. Yeah, something really specific to DPDK, we are offering an early access to most of the hardware features. That's really a good thing. And probably that's something that being in user space can offer. It's easier to offer different features. But the consequence is that each time we are adding a new really different feature, we have to think about the API to use this feature. So we are constantly in an unstable API. That's something we should accept or not, it's open to discussion. But currently, the feedbacks are it's good to have access to every hardware features. And another idea when using this new feature is sometimes some features are really specific to a hardware. So there is no point to provide a software emulation for this feature. And probably there is no point to put this feature in a generic API. So probably we can try to put some really specific feature directly inside the driver. So the application must know it is using a specific driver and use this feature directly from the driver header. Some word about other hardware specifics. We are seeing that, that there are some needs to have some custom mempool handlers. It is new in DPDK. Maybe not used, not publicly. I think we will have some use of the custom mempool handler really soon, probably for the SOC, the NPU. And it's related, we are going to discuss an event-driven model, something really close to what ODP is doing. So that's a good sign. And we will see what we can do with these new features. Some word about packaging. So DPDK is used sometimes with some static libraries, but when it is packaged in a distribution, we need to use a shared library. Maybe it's less efficient, but it's better for distributions. And drivers are used as plugins. It means drivers are some shared libraries, and you can choose to pick them, to load them or not. Yes, there was a new installation of DPDK in the version 2.2. It was a requirement for distribution packaging. And now DPDK is packaged in distribution, Fedora, Red Hat, Ubuntu, and Clear Linux from Intel. So it's a good achievement. Debian is in progress. Yes, just some word about the image. I don't know if you know it. It's a delivery service, DPD, is the name. And the old logo of this company was more like DPDK. You see, I can see the K in the logo. Not sure it is the original DPDK. Okay, some quick word about bypassing the kernel. Some kernel drivers are able to give the hardware access to the user end directly. Like the good example is with Mellanox using RDMA. You can have a userspace driver without anything else than the Mellanox kernel driver. It means that the Mellanox PMD is really small compared, for example, to the Fordville driver. So that's a good model. We can think about it for new drivers. Other way of bypassing the kernel is using UIO. We have the IGB UIO kernel module, but it's an out-of-tree kernel module. It's not good for maintenance, especially. And in the in-kernel, we have UIO PCI generic, but it cannot be used for VF. So now we have a new kernel module, which is VFIO, which uses IOMMU, which is more secure. About the performance, we don't really know yet. But there is also a new mode in VFIO, which is no IOMMU, which is usable in more environments. Talking about environment, it's running on Linux, on FreeBSD, maybe one day on Windows. And should we think to run DPDK in other environments, like unikernel? That's an open question. And another environment which will be really useful is to be able to run a full DPDK without huge page, especially for testing. It could be really useful. And if we want to run DPDK on more environment, probably in environment which doesn't support huge page, it can be an interesting work. Some word about usability. Yes, we are working on having simpler options. We have to avoid the built-in configuration, especially when you are doing a feature which is specific to a driver or which is specific to an architecture. Please think first to the runtime configuration. think first how can I optimize my code at runtime. Because build-time configuration cannot work when DPDK is distributed in a Linux distribution, for example. That's very important. How can we configure DPDK at runtime? We can configure it from the application with some API. Currently, we have an API based on RCRV, and everyone knows it's a wrong API. We have to work on it and have more function to configure DPDK. But we can also configure DPDK from the command line. That here it's not the application which is configuring DPDK, it is the user. The user sets some option on the command line. The user could set some option in a configuration file. It's something being discussed. Or the user could use some configuration option which are specific to the application. After all, is it the responsibility of DPDK to provide some configuration option, or should be the responsibility of the application? It's open. Another change important in usability, we are moving from a framework which was designed for bare metal and Linux, and now it's really a library. But that's still a long road. For example, DPDK is still complicated to compile, to integrate in existing application. Like any standard library, we could use a generic system like package config, and not mandate application to use a DPDK build system. That's obvious, but it has to be done. There was some problem with the logs. I think it's fixed now. Whether the application can use their own log. DPDK must not force the application to use the DPDK logs. Okay, and DPDK must force nothing to the application. That's the same thing for the design. Should we force how the application want to manage their threads? We are at the moment, but that's open also to discussion. And last thing, when DPDK thinks there is something wrong, it just exits. But okay, maybe the application wants to do something else when DPDK is wrong. Maybe the DPDK is not the only thing in the application. So we have really to think now DPDK as a library which must be cleanly integrated in any application. That's important. And to be a real library, we have to improve the developer tools. It's something in progress. Should we work on more language bindings? Today it is used in C application, in C++ application. Most of the time it works with C++ applications. Should we think to other language? Especially now we have some new networking language like P4, eBPF. Do we want a binding with that? Probably. As I said, the DPDK is achieving a lot of different things in different environments, and we have a lot of consumers now of DPDK for different reasons. For the leveraging the hardware, for the user space easiness, for the performance, obviously. And it is used in different distributions, in different stacks, for different traffic generators. There are a lot of views being created. Okay, why am I saying that? Because it's really great to see DPDK being used everywhere. And even greater, it's good to have more contributors, to have more use cases. At the beginning, it was Intel DPDK, and people were working on it. Separately, we were seeing some improvement somewhere, but it was not shared with everyone. Then, since dpdk.org launched at 6win, we can gather every contribution. That's really nice. And in the same time, there were some other projects working in the same area as DPDK, like VPP. Now it's open source. It's nice. There are some, maybe you know them, the project from Italy. These three projects come from the same university. Maybe you doesn't know. They are friends. Yeah. Okay, so it was really some important years for user space networking. But now DPDK is gathering a lot of contribution and a lot of companies, so that's really great. Even the kernel is starting its networking, performance networking solution. So it proves something, probably. And now the best achievement is to have more CPU supported in DPDK. We have IBM Power and ARM architecture. That's really so nice. And we have a lot of drivers. Maybe next year we'll have some new type of hardware like NPU. It's going to be a great year next year. And as discussed yesterday, probably we change the structure to according to the change in DPDK, to the growth of the community. It will be discussed on a new mailing list, moving at dpdk.org. To conclude, I would like to thank every contributors, to thank every new contributors for next year, and especially for this year, I would like to thank the ARM community, and I would like to applaud them. Thank you. And that's all. Thank you. Do you have some questions?
Regarding those optimizations that we could use from GCC, you have described some options. It's not clear to me if there's some options we could use, or you have already tried some of these. Like, for example, this flatten function from GCC.
The flatten function is used a lot in VPP. Maybe, do you confirm, VPP guys, the flatten attribute? Yeah. And what is the question?
This is not something you have already tried with DPDK core?
With DPDK, no, in DPDK it's not used. It's still not.
But your suggestion is we could use maybe that option or not? It's not clear to me why did you talk about that option?
Because if we want to ask to GCC to do some automatic optimization, the flatten attribute can help to have this optimization not only in the function which is going to be optimized, but also in the called functions.
Okay, so it's not something you have tried yet.
Yeah, but it works for VPP, isn't it?
So, issue is that if you have a mem copy like in DPDK, which is basically a function defined using heuristics, it doesn't use the AVX2 version. So the problem is that when you use flatten and then you put call the mem RT mem copy, it will not be use the AVX2 because it is basically selected by a preprocessor.
Yeah.
So that is the issue with that approach. Beside that, the normal C code is normally optimized for AVX2. If you specify an optimized flag that it needs to use AVX2, for example.
Okay, thank you.
So Thomas, I hope this isn't a really difficult question, but you've called out loads of things that we need to look at, and I agree with pretty much all of them. But if we were only able to fix or to look at one of the many things you've called out there, what do you think it should be? Of all the things you called out, what do you think is the highest priority in your mind?
Sorry, I'm not sure to get it. could you repeat, please?
Okay, you've called out lots of things that you think we need to improve and the things that we need to change.
Yeah.
What do you think is the single most high priority one of those? What one would you choose to tackle first?
The first priority, CI. Because I talked a lot about continuing to have some optimization, make sure that these optimizations are working everywhere, on every hardware, but at first we have to be sure which performance do we have today. And the performance number are not advertised. So first, let's do these performance measurements in a CI, in your CI, with your use case, your hardware. Then based on this, make sure we have no regression, and then we can continue to improve and have more optimizations. Yes?
Yes, just one comment also about the other attribute, target clones.
Yeah.
So to ask the compiler to do a version for each flag set of CPU.
Yeah.
It's quite recent, that explains why we don't use it yet. It's only with GCC 6.
Not exactly in previous GCC.
You have two attributes, there's target and target clones, and I think target clones is only GCC 6.
Yeah. But by the way, it's open.
But you can basically do it without that attribute by basically creating the wrapper function which uses flatten, and then it will basically wrap your function. It will with flatten GCC will basically create the full duplicate of the function, and it will apply different optimization to it. So that target clones is actually not. You can achieve the same effect, but with simple wrapping the function inside another one.
Yeah, so basically Olivier said target clones is a new feature in GCC. Yes, but maybe we can start using some new GCC. That's what I wanted to say. And Damian is saying in VPP we are using some wrapper, some macro to avoid using a recent GCC. Yeah. Right?
Do you know if does it work without a function pointer? I mean, in VPP you are using a function pointer to...
Yes.
Yeah. The difference with GCC 6 and the target clones attribute is that it's really fully automatic. That's convenient.
So probably these new attributes aren't supported in the...
Sorry, I don't hear.
I said the new attributes, are they supported in the other compilers like Clang and things like that?
Clang, yes.
It is? Okay, good.
Two more questions to that. Can I?
Yeah, please.
So, over here, the other arm. Sorry, over here. Two questions. So one thing is, those two things, all the optimization discussion goes very much along your personal need for CI and what you want, because all of that requires everybody to agree that afterwards it was actually an optimization and not a degradation. So those two, it's not a matter of priority pick. You need the verification first to have some sort of progress. But that's just a comment. The other question was, since so many people seem to have tried with all kind of experimental and non-experimental GCC features and stuff, I want to ask if anybody ever has touched profile-directed feedback for any DPDK-based solution. Okay, Steven?
I did a short test, and on one box with our application, it was, what was it, like 2% or something? Yeah, and it was, the problem is more that the data gets stale. So you basically, typically you have to go take an application, take a profile of the application use case, run like, you know, Aspirate or something, get your data, then take that data and feed it back into your build process and iterate. And that is not something that A, is generally useful for distribution, and B, if you're in a development environment, you can't normally do that as a sustained process. There are companies I know on other products like Google and so on have done it as we're going to do it as the last step of our production deployment build process, but it's something that you can do with the DPDK, it's just really painful for your packaging and build.
Yeah, I totally agree. That's something that I would like in a distribution, but the question was, since there are so many vendors, which in the past, like statically linked and all that, that would be the perfect thing, because you have your one use case, to some extent you even know your hardware and your setup, which is like all of the checklists for PDF to actually work. But yeah, it's good to hear 2% experiment. Thank you.
Yes. Yeah.
So these different optimization techniques that could be used in DPDK, and some of them are used in DPDK, is there any place in the DPDK website, wiki, documentation, whatever, that describes these different techniques and how they work and what can be achieved? Or are you pretty much on your own if you want to? I'm considering, if you want to contribute something to DPDK, or you want to optimize something in your own application, then it's good having some sort of overview of these different optimization techniques and where they might apply and how they work.
Yes, as you know, we have a lot of documentation in DPDK, some guides. We have some sections, for example, about which design we want to use in DPDK, and we can add some section about which technique are usable for DPDK to optimize DPDK. I agree, but I cannot really commit today to have this documentation because many persons must contribute to it. But yes, it's welcome.
I'm just raising the documentation awareness.
So,
Yeah.
so the book you have in your hand, right? The cookbook, what you have, there's a chapter, I think almost like 40 pages. You may not be touching all of that, but it is mainly focused on optimization techniques. So you can look through that, and then if you have any suggestions to improve that, please let me know. Thank you.
Okay, just two minor things, I think. One is we, in our testing, and we are going to try to make a lot of it public, we've seen different distros provide significantly different performance. So one thing I'm not sure if we want to have everybody do testing on the same distro, or just any numbers from a particular processor or NICs do it on the same distro. But then again, the DPDK, we always advance distros. So we've got that kind of little mix here, because we do find that, like Ubuntu does provide better performance over some of the others. So that's a problem in that respect. So I'm not quite sure how we deal with that part. The other aspect is, well, I agree with, I mean, we definitely are always looking for the enhancements. How do we get better performance through all these different means? The one thing we always have happen is we have to still support some of the old distros. There is quite a few companies, and I'm sure you're aware, they will not move. They will stick on that distro for ages, an old kernel, whatever. So we have to be careful with some of these enhancements that they don't actually break some of the older implementations, the older distros that we're running on. So we do test a lot of those as well, just because of that issue.
Okay. Is it a question or?
No, just a point. Just a point to make people aware of that. You know, you do have different performance with different distros for various reasons, and so that's an issue from that point of view. And that you make these types of advances, you have to be a little cautious about that. They do work in older distros.
Okay, please let me be more precise on the test. Okay. Today, DPDK is made by mainly by some hardware vendors, the CPU vendors and the device vendors. So we can expect these vendors to do some performance testing. It means you try to show how it behaves with the feature you love in your hardware. And that's okay, because probably that's what the users want. But it will be even better if the test comes from the DPDK users. Because after all, what is the goal of DPDK? The goal is to be used. So the important performance numbers come from the users. We can try to mimic the users' numbers, their use case, or you can ask them. And for example, DPP is a great user of DPDK. I'm sure they can provide some interesting numbers.
Okay. Thomas, thank you very much.
Thank you.